Hey everybody, my name is Garrett Liles. I'm an associate professor at California State University-Chico or Chico State, and I'm going to be sharing my Science of Soil Health project, the Agro-Systems of NorCal edition. So what are we going to do today? We're going to talk quickly about how soil health is a logic and critical thinking approach, a 9-step program. We're going to talk about how working in California can be a challenge, exhilarating and amazing, but it has its difficulties. A quick history lesson about our mythical Vina soil in the North Sac Valley, the approach we took, some data, and then a little closeout on the real impacts of this project. So the big picture here is soil health. We should all care about it. My definition is the collective effort or consciousness to ensure humanity persists, i.e., making sure ecosystem services are flowing positively from these systems. This is an important issue, not just for us today, but for our children in the future, related to climate change, water. Every important issue humanity is going to face really gets boiled down to soil health and how we make sure that we shift towards that being the focus. So soil health really is a critical thinking opportunity or exercise with 9 easy steps. This list came from NRCS technical documents. So identifying a problem, we know that we have a problem. We have to determine some objectives. We develop an inventory and we analyze data that we collect. We think about alternatives and evaluate them. We make decisions and implement them. And then we evaluate or iterate. This is the most important part, right? Is that iteration, what's next, and scale up. Well, where are we at in these Science of Soil Health projects? I would say that we are here clearly, inventory and analysis. So California is an amazing place to study soils. It has great diversity of geology, topography, precipitation, creates amazing diversity of soils over short distances, but it also makes for some challenging decision making when you think about something like trying to measure soil health. We have 9 soil orders. We don't have spodosols or gelisols, and we do have a small paleoxisol, but overlaying on that is 400 commodity systems, diversity of management. It makes a needle in the haystack kind of an approach. How do you start to measure soil health? So I got this award. I'm a pretty new professor at the time, and I'm like, let's use our university farm. Let's look at our local area, right? Let's look at soils in the northern Sacramento Valley. Here we are, California, the polygon of the North Sac Valley right here, the alluvial fans of the Southern Cascade, right? And our university farm is an anchor of this to both highlight it and to be able to provide some connectivity between the local land uses and the soils that we manage. So quick backstory about names and soil survey. It's really interesting to me. Growing up in Chico and growing up in the area, I had heard about some of these names, and when I had the opportunity to dive in more related to my science, it made me really excited. So first off, let's talk about Peter Lassen, overland pioneer, rancher. He's the namesake of Lassen Park. And he came across the country as an overland pioneer, and in 1844 he was given a 22,000 plus acre Spanish land grant called Rancho Bosqueo. Between 1848 and 1844 and 1849, the gold rush happened, right? And the world changed. And Lassen gave up 2/3 of his land in 1850 to get money so he could do gold exploration. It didn't quite work out. He wasn't a good businessman. And ultimately, the rest of his ranch he sold to this gent Gerke not too long after and got out of this business altogether. So fast forward to 1841 and Leland Stanford. Stanford was one of the big 4, right, that helped finance and push forward the train from the West Coast, from Sacramento, to get to Promontory Point in Utah. With his money that he had, he ended up buying this Vina Ranch, a 3,500 acre spot left over from that land grant, and it quickly became the world's largest vineyard. Within 12 years, Stanford had died, and his university, which was 150 miles or more away to the south, started selling off land to get rid of it because they didn't want to be in the farming business. Fast forward to 1919, so about 25 years later, and a 200-acre block was sold to a group of Trappist monks that still own the property, and it's the new Clairvaux Vineyard where they do wine and they do orchard crops, which is part of the story here. But the thing is that this became the Vina Ranch, right? This is the town of Vina. Leland Stanford called this place Vina, which became very significant moving forward as a local soil name. So initial survey for Chico in the Western Butte County area was completed in 1925. One of the soils was identified called the Vina, right? Deep alluvial loams. And when I was growing up here, and to this day, people still talk about having Vina. I got that good Vina soil. It was the name of the good stuff that you could do anything with in the area. This Vina and this Conejo, which we'll talk about here in a second, got carried forward to today. In the late 90s and into the early 2000s, the area was finally resurveyed, right? It went a long time, 80 years on this original survey. And this Vina became multiple series, right? There was the Conejo, which we already saw, the Vina. We got a new one called the Almendra, which means almond in Spanish, the Charger, and the Chico, right? So this is not a huge coverage of these soils, which I'm kind of considering comparable or close enough. They function similar. They're used for similar land uses. But it's not insignificant, about 150,000 acres of this in our region. And this is primarily a nut crop producing soil, right? Pretty much all the soil in this area is used for growing nuts, with a little bit of annual crops, mainly at our university farm, which we'll talk about now. So instead of doing, I tried to do an end-member approach, a reference, a highly disturbed annual system, like kind of our least soil healthy type of management that we have, and then our common system, perennial walnuts. So we were able to use our university farm down here at the bottom. That's where the annual cropping occurs, and we have some nice reference sites of Valley Oak Woodland Savanna and lots of walnuts. Right here, we'll see. This is the Chico loam, which we saw a second ago. This is the Almendra pits from our farm, and a nice monolith that this hung up in the university art event a couple of years ago. So what did we do? We did 3 pits at each site. So each site by management combination, or at least we tried. We got 3 sets of 3 pits in annual, 3 sets of 3 pits in the orchard crops, and a couple of reference sites. It was great. We did all the field assessment, sampling, data development, photo documentation, monoliths, and a ton of folks got experience and are still benefiting from our monoliths, the data, and these other things I'm going to talk about now. So, got to some data, right? This is all about a data-driven approach. This is really an observational experiment. It isn't a manipulative experiment. We're just going out and reporting on what we see. So, I went through, I'm going to talk quickly about pH, EC, soil carbon, POC, and aggregate stability. So all the graphs and figures will be the same setup. We did kind of normalized depth classes 1 through 5, reference, annual, and perennial. So first off, we see very clearly that annual cropping in these soils does what it does in other soils. It lowers pH. Continuous, regular tillage, fertilization, irrigation water can do that, where the perennial system without that disturbance and a different type of fertilization regime provides a more of a reference looking signal, which is great, because the perennial nut systems is not a bad trade-off if we're not going to have oak woodlands, right? So electrical conductivity, not as clear of a story, but we do see the influence of fertilization, tillage, and irrigation on elevated EC in the surface of the annual, lowest in the reference. You can see we only had a couple of pits in the reference, but more variability in the annual as well, right? More disturbance, more fertilization, more inputs. So carbon plays out as you might think. The annual cropping, which is heavily tilled and disturbed on a regular annual basis multiple times a year, has the lowest surface soil C% carbon. The perennial system, which isn't tilled but doesn't have a cover crop, isn't intentionally trying to enrich surface carbon, is kind of in between, and then high numbers and fairly high variation in the surface soils of these undisturbed oak woodland systems. So that kind of holds up with what you would kind of expect, right? And the idea is that if we go more orchard, we're going to store some soil. If we start changing these orchard systems and managing them differently, we could start to nudge them forward and increase soil health and increase carbon storage through some management changes. POC, what you would maybe expect a little bit more, higher POC in the reference where there's less disturbance, less tillage, and a kind of comparable in the annuals and the perennials with the higher POC in the surface and decreasing with depth. This is probably the most startling of all the data I present today, the idea that aggregate stability in the annual cropping system here in the center was drastically reduced throughout the depth of the profile, right? Almost half what you would find in the reference or in the perennial systems in the surface soils, and lower across the board here and here, and then kind of normalizing a little bit deeper, and then a dive off at the bottom. It's really, I've thought about this multiple times, and I still don't have a good answer of why this is, but it is one of the more startling results that we got out of this entire project. So take-home messages for now is nothing too earth-shattering, right? We reinforce some things that we already knew, and I think that subsequent to this, we realized that those orchard systems, if we start to manage those better, we can make some benefits and make some changes as we get rid of some of the annual cropping and go towards even more of the perennial systems. This is obviously, the significance is going to come from local things, which I'm going to talk about now, and the project-wide analysis. What does this mean for the project? And then just more data and collaboration. What this project helped us do was kind of a local lasting benefit. It helped us create the Regenerative Ag Demonstration Lab, or the RAD Lab. So now we have a soil health service lab with enough capacity to work with our own projects and our own partners, plus taking soils and analyzing them for folks, industry and otherwise in the public. We have some physical spaces, super high-tech labs here, some beat up old building and a beat up old greenhouse. We do our processing. We have a lab manager and staff. We have a ton of students that we train, and people learn and come and learn about soil in these spaces. This project also helped us get an NLGCA, non-land grant colleges of agriculture, NEFA grant, to get a new combustion analyzer, and a Bruker Alpha field office instrument that aligns directly with NRCS's efforts to use mid-IR, which is really exciting. We also have started some science communication work and a campus carbon project where we're doing similar work on campus landscapes to build greenhouse gas inventories and understand soil health and carbon cycling on our own campus relative to different land uses. Finally, this grant was amazing. We've been able to leverage this multiple ways in getting matching funds for other grants. And our Center for Regenerative Ag, which our lab is part of, recently was awarded a Regional Conservation Partnership Program Award, which is called Soil Health Management Systems for Northern California. And we'll be able to use this infrastructure, the data we can generate, and implement some of this science across our region in very tangible and important ways, using the RAD Lab and this whole project as a way to make that happen. So with that, that's all I have. That was fast and furious. If you have any questions, please hit me up at gcliles@csuchico.edu. I'll share with you what I know, successes and failures. And with that, I thank you. Have a great day, and keep sharing your love of soil.